What would be the first step you guys would take in solving this?
Get rid of the bottom and put them equal to each other?
I saw here combine like terms, get rid of the bottom. Okay, so how would we get rid of the bottom?
I mean, there's exactly the same base, so you can just work the top instead.
You can definitely notice that. Now, what if it's the case where, what if they weren't the same base? Like those exponents cross multiply. Yeah. So Edwin pointed out something really good. He noticed that both of my denominators are the same terms. So you're more than welcome to go ahead and start working with the numerator, but it might not be the case where they're always the same. So if you were to cross multiply, we're going to see why these two things are going to cancel out in a second. It'll be a surefire answer every time. So I'm going to go ahead and multiply 5x by x minus 2. And I set that equal to x minus 2 times 3x plus 4. Okay, so now, it's diagonal, I'm sorry. So now at this point, you're welcome to distribute, but I also notice that I have common terms. You can divide x minus 2 on both sides at this point as well to get those two terms to cancel out. But I'm just going to go for the long route just so we can, it's nice and scenic, right? So I'm going to go ahead and distribute the 5x here and here. 5x squared. This is the way that I'm going to solve it, but you could also divide by x minus 2 on both sides too. 10x is equal to 2 right here?
No.
10.
You would have to subtract the 3x because you want to have them by itself. You never want to have 5x and a 3x on
squared, yes.
You want to have one of each. The one that has the 5x, the one that has a regular. You want one side to have an x and one side to have normal. Subtract the 3x on both sides.
Okay. I'll slow down.
It's the same thing as putting one over.
Now the reason why I'm going through this way is because for example, they're not going to be the same tomorrow. So it's good to just kind of practice with both ways. This was kind of an accident. All right, so now that I went ahead and FOILed, I'm going to solve for x. So I want to get all of my terms on one side of the equation. And if I start off by subtracting the right side, I'll have a positive x squared. So I'm going to go ahead and minus 3, add my 2, and add my 8. So minus 3 over here, adding 2, adding 8.
X multiplied by 3x. Yeah, because that one you're distributing each one. The other one says it's just one. Yeah, that one is just one number. 5x. So you only distributing x. The other one is x minus 3.
So now we need to solve for x. So what I would do, so now you can solve for x anyway. You can do completing the square, you can quadratic formula. I'm going to go ahead and divide by 2 because I noticed that each of my terms are easily divisible by 2 and that might make it easier for me. So divide by 2, divide by 2. Thank you. So then that gives me x squared minus 4x plus 4. And now I can just think, what are two factors of 4 that will multiply to give me 4, but add to give me, -2 and -2, right? You're gonna pass. You're gonna do so good on this test.
Yeah, I know, right?
I did it a different way.
Mhm.
And I wouldn't even do it that way if it was different. I would do whichever. I would keep plugging in numbers until the x's would match up for both of them.
Mhm.
So for like I think that's how I found this one out. But for like 5x, I'd put in like 1 and then 2.
That would take you forever, though.
And then so that they both match up.
Like your numerators?
Yeah, and for both of them.
That, I mean,
But
that could work.
But at the bottom it has, since it's 2 minus 2 would be 0.
That's why, like I said, this was a bad function altogether. I chose a bad function. But yeah, that guessing and checking, it would work, but yeah, it would take you a while.
Okay,
Quite a while. Yes, sir.
Is there a show way to do it?
What other? So I was saying, there's multiple different ways that you can do this throughout the problem. You could have multiplied by your denominator on both sides. You could have divided by x minus 2. But this is the surefire way, Miguel, to get the answer every time.
That's a lot.
It is. There's a lot of steps. I agree. I don't want you to cry, though. It's doable. All right, so do I have any other questions on the first one?
That's when you factor. Fine tune it. It'll be the same.
You're pretty.
It'll be the same, but we'll add up.
You're good, Joaquin? Yeah. All right. Okay, so let's go ahead and move on to this one. So what would you guys do first if I wanted to get rid of or solve for x? Yeah, I'm going to maybe add 1 on both sides. Before I multiply, I want to get rid of this constant. So I'm going to add 1, and I'm adding 1. So now I have 3x plus 1 all over x plus 4 is greater than or equal to 1. Okay, now what? Yeah. I wanted to, if I have a fraction and I feel uncomfortable working with them, why don't I try to work to get this denominator out of my problem? And in order to do that, I can multiply both sides by x plus 4. So that's what I'm going to do. X plus 4. So then those two cancel out. I'm left with 3x plus 1 is greater than or equal to x plus 4. Okay, and now I'm solving for x. So maybe I might subtract x on both sides and then minus 1. Would you agree, Brandon? I said maybe I might subtract x on both sides and then minus 1. Yeah? Okay. So I've got 2x less than or equal to 3. Not yet, because I want to get x by itself. So what's my last step? Divide. Divide by 2. Exactly. Greater than or equal to. You got it.
Okay, that just looks very weird.